Hello everyone. In this video, we're going to continue our discussion of nested conditionals by learning about multiple alternative if statements. For our warm-up task, go ahead and open up guessmynumberfun.cpp in gedit and just make sure that everything is working. We're going to continue writing code in this file for this video. So here's where we left off in our last video. We had moved the if statements that provided the hints to our user into the body of our else statement that was essentially writing code for when the user is wrong. Now we did this in order to make our if statements nested, which means they are part of the body of another if or else body. Now there's something called a multiple alternative if statement that combines this relationship right here, where we have an else, and nested inside of the else is an if statement. There is a reserved word in C++ called else if, and we can use else if in order to clean up code that has this kind of relationship. So let's take a moment first and review the term mutually exclusive. We talked about it briefly when we learned that the bodies of an if and an else are mutually exclusive, meaning only one can execute per execution of our program, not both of them executing on a single execution of our program. So if we just type mutually exclusive into Google, you'll see that mutually exclusive means that two events cannot both occur, or they both can't be true. A clear example is the set of outcomes of a single coin toss, which can result in either heads or tails, but not both. And here's a Venn diagram that shows two events, A and B, and there's no overlap between them because they cannot occur at the same time. Something can't be both A and B. They're mutually exclusive. So I'm bringing this back up because we're going to use the term mutually exclusive again when learning about multiple alternative if statements. So back to our code. Let's label the Boolean conditions in our code so that we can refer to them by name. Let's call the first one BC1. Remember, BC is short for Boolean condition. Our hint for too low, BC2. And our hint for too high, BC3. So the way we currently have our code set up, BC1 is executed first. If BC1 is false, then we enter the body of the else statement. BC2 executes, and regardless of the outcome of BC2, BC3 executes as well. But something that we can observe is if BC2 is true, there's no need to test for BC3 because user guess cannot be both less than and greater than secret num at the same time. It was actually the same logic that we used in order to push BC2 and BC3 into the else, because we knew that there's no need to give a hint if the user guessed the number. So we can't have equality when testing both less than and greater than strictly. So given this logic, we're going to construct something called a multiple alternative if statement. And with multiple alternative if statements, we'll use the else if keyword, which is like an else with a Boolean condition to test. This isn't a Boolean condition that we're putting as a comment to help us understand how if-else statements work. This is an actual Boolean condition. So let's code it up, and then we'll trace through it and explain it. So we can combine this else with the Boolean condition of this if with an else if. In fact, in order to do this, I'm going to simply delete all of the code I currently have highlighted. I'm going to fix the indentation And now everything above line 22 looks good. Here's how this code executes. It's sequential top to bottom. So first we test BC1. Let's say the user correctly guesses the secret number. We'll enter the body of the if statement just like we would before, and we'll print out, you guessed it, nice work. Now, if and else if Boolean conditions are mutually exclusive, which means if ever one of these Boolean conditions evaluates to true and the body is executed, there's no way that any of the other bodies can be executed because these Boolean conditions will not even be tested. They'll be skipped. Now let's say that the user guessed incorrectly. BC1 evaluates to false. Then the next Boolean condition in our multiple alternative, okay, multiple alternative because we have different alternatives of execution other than just an if-else. The next condition in our multiple alternative if statement will be evaluated. So we'll come down to BC2. Let's say they did enter a lower number. Let's say they entered in 3. 3 is less than 4, so the body of this Boolean condition, this else if, will execute. Now, we could have another else if here, and this else if would only be evaluated, this Boolean condition, BC3, when BC1 and BC2 are false. But if the number is not equal to secret num and it is not less than secret num, then that means it must be greater than secret num. And we can actually replace BC3 with a simple else. Now, let's go through this one more time, but let's make some notes as we do this. So, alternatives are tested from top to bottom. And by alternatives, I mean Boolean conditions. As soon as one evaluates to true, that body is executed and no other BCs are tested. You can think about this like skipping to the next executable statement after the multiple alternative if statement. And by multiple alternative if statement, I mean the whole structure. Okay, a few other things to note. Each body is mutually exclusive, which means on one execution of this program, at most only one body will execute because of what we wrote up here. A few more notes to make. You can have as many else ifs as you want. There's only one if, and it has to be first. Only one else. It is optional. You don't have to have an else. In fact, we saw that earlier. It is optional, but if you have it, it has to be the last body, meaning at the end of the multiple alternative if statement. So let's save, compile, and run just to watch it execute one more time. So we'll guess 4. You guessed it, nice work. Okay, 4 is equal to 4. So the cout statement in here displays, and then the rest of the multiple alternative if statement is skipped over. So essentially it's like if there was an executable statement here on line 34, that would be the next executable code that is run. Okay, let's run it again. This time, let's say we do 2. It says you are too low. 2 does not equal 4. So at this point, in order to test BC2, we know user's guess does not equal secret num. That's the complement of BC1. And we enter the body, you are too low, and then execution skips the rest. So this does not occur, and we head down to here. Now let's do a larger number, like 7. 7 does not equal 4, so we come down to the else if. 7 is not less than secret num, so we come down here. And for this else, we actually have the complement of BC1 and the complement of BC2 true. So let's write that whole thing out just as the last thing, or last note we make about multiple alternative if statements. The only way to get to the else is user guess not equal to secret num is true, and user guess is less than or equal to secret num, because not user guess less than secret num is user guess, greater than or equal to secret num, which essentially, since we have inequality here, we know this means it must be strictly greater than. So multiple alternative if statements are really nice because you can convert nested conditionals into multiple alternative, and recall that you can convert multiple alternative back into nested, because we could have had this code execute exactly the same from when we finished our last video. All right, the last thing that I want to do to wrap up our conversation about multiple alternative if statements is refer you to the notes for some additional reading. These bullet points here are more formal rules that you can use in order to understand multiple alternative if statements than the ones that we derived based specifically on our BC1, BC2, and BC3. One in particular I want to show you an example of, this last one. The compiler always matches an else with the most recent incomplete if. So initially, looking at this code, you might think, okay, where are the curly braces? That's a compiler error. The compiler only requires curly braces if there's more than one statement that belongs to a body. That means if the body of your if statement or your else if only has one statement, then you don't need to add curly braces. The compiler can figure out which if statement that is. However, I don't recommend doing that. It can make your code really hard to read and quite difficult to debug. For example, take a look at this code. It's very difficult to see what the programmer intended when they wrote this code. For example, here we have if temp is less than or equal to 32. There's no curly braces, so here is the one statement that belongs in the body of this if. However, the way the indentation is set up is it looks like this if statement belongs in the body of this if statement, but because there's no curly braces, it doesn't, which means this else actually belongs to this if. And if I fix the indentation, that becomes a little bit more apparent. But without those curly braces, we've got another problem here related to what is the one statement that the compiler thinks is part of the body of this if statement. So there's quite a few problems here. And how would you fix it? Well, here's one fix. The other one is definitely using curly braces. And I recommend you use that for all if, else if, and else's even if they only contain one statement, because then you won't have any problems about figuring out which else belongs to which if, or which else if belongs to which if, or which else belongs to which else if, for example. A few other things that I want to emphasize related to conditionals. A common error that you will come across probably at some point is accidentally using the assignment operator instead of the equality operator in your Boolean conditions. For example, let's say that we want a Boolean condition that looks like this. We want to test if x is equal to 5. At some point or another, you might accidentally just write x is assigned 5, and it's going to be quite difficult for your eyes to catch this error. If this happens, x will be assigned 5, which always evaluates to true because 5 in this case is not 0. So when this assignment successfully takes place, this will always evaluate to true regardless of even setting x, say, to 3 right before it, which will be very, very hard and very, very frustrating to track down. So always be on the lookout for this. In your if statements, I would say you never want to have just an assignment here. The cases for that are very rare, but in 121, you'll never want an assignment here. So always get in the habit of writing your equality operator when writing a Boolean condition and not the assignment operator.